Alright, here we go, Advent of Code Day 15. I'm going to try a different parsing method today. We'll see how that goes. Oh, that's the puzzle input. Never mind, not doing that at all. Okay, so playing a memory game, list of starting numbers, each turn considering the most recently spoken number. If that was the first time number has been spoken, the current player says 0. If the number had been spoken for, the current player announces how many turns apart the number is from when it was previously spoken. So after the starting number, each turn speaking either aloud a 0 if the last number is new, or an age if the last number is a repeat. So 036, 6. So that's 0. Been spoken before. Cool. Excellent. Great. So now we just need to do a while true, well, for I in range age. Okay, so prev index that. If I is less than length of L, then we need to get we just so index 0, index 1, 20, 2, 11, 3, 6, 4, 12. Oh, this is the wrong ordering. So we want that 1 is index 0, 20 at index 1, 11 at index 2, 6 at index 3, 7 at index, 12 at index 4, and 0 at index 5. Great. So now we want for I in range 6, 20, 21. So the first thing we're doing is index 6. And then prev, let's just call this mem for memory, so remembering what the previous index was. Prev is equal to 0. And then we want to say, okay, so if it's the first time, then you say 0. So, great. So if prev in mem, else. So if it has been spoken before, then you say the last time that it was said. Otherwise, you just say 0. Okay. I'll append. Fifth number spoken is 3. I minus mem of prev. And then we want to say of I minus mem of prev is equal to I. And we want to say mem of 0 is equal to I. Print L of 2019. No way that's right. Zero, 1, 0, 79. Yeah, it's just counting up. Something's wrong. L dot append 0. This is never getting triggered. We're forgetting to reset prev. Let's just, instead of doing this prev thing, let's just get the last element in L. L of minus 1. L of minus 1. L of minus 1. Key error 7. No, that's not quite right. We're getting there though. This is going to be a slow day, I can already tell. I'm not figuring this out immediately. So, key error. Yeah. Interesting. Okay. So mem needs to be something else. So here, so it could be a map of numbers to lists of all the times that they've been said, and then we just need to remember the last two, really. That would work. There's definitely a better way of doing this. Find all Python. Find all index of element in list. Okay, well, there's nothing quite as concise as I wanted, but I will take it. Let's just do this, because this seems simple enough. And I don't have to import anything. So indexes equal to boop. Let's get rid of that. I for I in range, length, and this is just L, and then if L of i's equal to I, and then let's use J just to be safe here. L of J is equal to I. Great. If len indexes equals 0, oops. First time. Well, length indexes is always going to be L of J is equal to L of I. 3, 4, 5. So I represents the index that we're trying to create. So this is looking at the previous one, which is what we want. So if the length is equal to 1, because it can't be 0, then we say l.append 0. Else the append indexes, or L of indexes of -1. Well, no, just indexes of -1 minus indexes of -2, I think. $10.85. A very, very, very slow, but I'm super happy with this answer. Like it's very concise. Impressed. Okay. Same starting numbers will be this number that is spoken. Let's see here. That's 300. Or sorry. That's 30 million. Well, this is definitely not going to work anymore. I knew this was what part 2 was going to be, and I still programmed this in a poor way. Very sad. Okay, so this works great for small numbers. Now we got to think about what we actually need to keep track of, because 30 million iterations, I think we can bust our way through. But we should only store what we absolutely need to and ditch this all this garbage that's about keeping track of the whole list and stuff, because what we actually want is I think that the initial idea that I had of a map of numbers to times that they've been spoken will work okay. because then we're not iterating through the whole list ever. So what we actually want, let's just comment this all out and start from scratch. And let's do one of the test cases. So L is equal to, or let's just make this new map, and it's going to be a map of numbers to when they were spoken. So this is going to be 0, and it's going to be a list at index 0, and we're going to be, well, let's do the 1, 2, 3 example. 1, 0, 2, 0, 3, sorry, 2 is at index 1, and then 3 is at index 2. Great. For I in range 0, 1, 2, 3, comma, and now we want if we need to keep track of the prev. That's the other thing. Prev is equal to 3. So to find the fourth element, so if prev in, so if prev's been spoken before, so if prev is in mem, we need a case else, prev's equal to 0, and we need mem of 0 dot append I. But if it is in the memory, then we want prev is equal to and in the end we just want to print out print prev. I believe this is all we need to do. Prev is equal to mem of prev. Oh, sorry. So if it's in memory, then we first need to get the list. So L is equal to, or spoken, or indexes, let's call it indexes, is equal to mem of prev. If length of indexes prev will always be in mem because it was spoken. This is the wrong case. So if length indexes equals 1, then we do this. Else mem of prev is equal to mem of prev of -1 minus mem of prev of -2, and then mem of prev I think we're safe to do this. it's running. The question is this quick enough? Given that it's doing this long, let's give a little if I module okay, so it's doing 1 million pretty quickly, and it's only has to do 30 million, so. So we're testing the 1, 2, 3 case. And we could definitely speed this up by changing this from being lists to tuples, where the tuples, like, it's just 2 negative 1s or something. So that's wrong. Lovely. Well, that's not great. Let's test our part 1 again with just a few numbers. Let's ditch that. And so let's just test it on 0, 3, 6, 0, 3, 6, and those are at 0, 1, and 2. And prev is equal to 6. And then we want 3 to range 7, why not? And then we just want to 0, 3, 1, 3, 1, 1. 0, 3, 3, 1, 1. Ah ha ha ha, we found a problem. Let's change this to 10. And we've got double zeros here? This doesn't make any sense because 0 is seen before. Okay, so let's also print out mem. Okay, 3. It's being said there too. Okay. Let's move this up here. We got a very slow day, and that's okay. So prev is 6, and then that's our memory. These are all the 3 times that these things were said. 0 was set at index 0, 3 was set at index 1, 6 was set at index 2. Excellent. So on the next day, we look at our previous number 6, and we see that that's the first time that it's been spoken, so the answer is 0. So we append index 3. Great. And then 0 has been spoken before, so they're using not 0 indexing, so that's 3. Excellent. 3. So we say the number 3, and the number 3 has been set at index 4, which is here. Great. 6, the last number 3 has also been spoken before, most recently in turns 5 and 2, or 4 and 1 in this case. So that we say 3 again. Boom, boom. So we got the 4 and 5. So on turn 7, we say 1. Great. And then we say 1, and 1 was set at index 6. And then since 1 is new, the 8th number spoken is 0. So we say 0. 0 set at index 7. 9. 0, since This last spoken turns 8 and 4. Next number set is 4. Wait. So we're doing fine. I think that we might just be off by an index or two. Let's try something. Cause we're doing fine here. Let's do up to 3,000,005. I don't know why, but let's do it. And let's say if I is greater than 29,999,999, print rev. So this will take a second. There's our answer. It's the very first one. So I was just off by an index. So let's get our actual input into this kind of a map. Mem is equal to, so it's the very first one here. Mem is equal to 1, 0, 2, or sorry, 20, 1, 11, 2, 6, 6, 12, 4, 0. Oops, that's a bit list. Oh, there should also be a list. 3, 12, 4, 0, 5. Okay, prevs equal to 0. Just waiting for it to spit it out. After I get this in, then I'll figure out a better way so that it runs a little bit quicker. There it is. Man, today was slow. I'm sure that my stats are very bad. Yeah, 1020 and 1831. Very slow on part 2. I should have predicted that part 2 was just going to be a let's make the numbers really big type thing. So let's go through and clean this up because I know we can do it. In fact, let's turn this into a function where we can figure out a way to parse this input into something, because I would like to put it in the input file and then be able to read from it in a clean way. And just, figuring out the indexing thing to do what we want. So, really what we want yeah, let's put this in our input and take care of the input parsing first. So our input is let's think of a good way to, because if we have a function that can push into these memory things the way we want, I think that'll be what we want. Def mem add, and what we want is the we want the number. Let's just call it num, and we want the memory. Okay, and let's think about how we want to structure this memory, because what matters is let's think a little bit about what we know for sure. So when a number's spoken, on the next turn, we're going to be looking at that number that was just spoken. And if it's spoken for the first time, then we say 0. If it's not spoken for the first time, then we subtract when it was spoken from the man, reasoning about this, for some reason I'm having a hard time. Like distinguishing between like the starting numbers and what you do after the starting numbers. I'm just having a little bit of trouble. Let's just get these numbers. Num is equal to L dot split on comma. And then we want to map it to integers. Map mem.x int of x. And all we want to do is for n in this, mem is equal to that. Can't get out of my head that we only need to remember one index when something's spoken, because it gets clobbered. Because if we know it was spoken previously, then we know it was at the index -1, right? So I think let's call it starting numbers is equal to I don't want to do this like this. Is equal to list of this. For n in starting numbers, mem add n mem. Great. For I in range of length of starting numbers 0. So what did we do down here? It was, so the length of starting numbers was 6, and we started at that length, which makes sense. And then we go till, so the thing that we ended up printing was the thing when I was 30 million. So this we should probably put inside of a function as well. Mem. Let's just call it solve. Be nice and not precise. Solve of, and what we really want is which, we want the starting numbers, and we want the index, the answer index. So first we want to just say these two things. And then for I in range, length of starting numbers to and's index. And's index, I think this is right. And then we just return prev. I think this might be giving us what we want. So now we have to decide exactly how this stuff's working. So I think that if we just map it from the number to the previous time it was spoken, and then we can do some fun stuff with prev, and knowing that it was the previous thing spoken. Okay. Prev is equal to starting numbers of -1. If so, now it's not the length of indexes. It's if prev. So prev is guaranteed to be in mem. Or actually, I think that we only want to put prev in mem because this is the thing that we've got. We always know that this first number is I think we need to not put in the last one. So prev is equal to starting numbers of -1. So if prev in mem, else. So if prev is not in mem, prev is something that is what we spoke last, but mem is if it's at least a turn old. So if prev is in mem, then we want to say, well, if prev is not in mem, then we then prev is equal to 0, so that gives us the next value. And the next value here, prev is equal to I minus 1 minus mem of prev. So it's I minus mem of prev plus 1, I think. we're gonna have all sorts of indexing problems here. I just wanna I think this is gonna be the right concise way of doing it, because this is messy. So when do we put something in memory? We do it at the end of the for loop. Let's say new prev is equal to, or cur, really is what we want. We want current. So, okay, so prev represents the previous number that was spoken without it being yet in memory. And so what we check is we first see this previous number that was spoken. Is it in memory? If it is in memory, then the current thing that we're about to say out loud is I minus 1 minus 1. I minus 1 minus mem of prev. And that gives us the thing that we're about to say out loud. And if it's not in memory, then the thing that we just set, the prev is new, and so it's 0. And then we say, hey, mem of prev, you can now set yourself to be the previous index, and then prev is equal to current. And then we return prev at the very end here. So let's see what happens when we solve of, and what we really want is 2020. We don't need that. All right. Wait, 1085. That was the right answer. Come on, baby. 10652. Wow, that is so little code for today. And it requires so much reasoning. Dang. Man, this challenge kicked my butt. Okay. Whew. Man, but I am so happy with how this is now. Like, this is so concise. Um, so what we're doing is we're keeping track of memory of everything, not just past the immediate previous thing. And we say, oh, what's the previous thing that was said in memory somewhere? If it is in memory somewhere, that means that it was said at least once before this previous time. And so this next number that we're saying is going to be I minus 1 minus mem of prev. So might as well put that there instead, because that's this makes more sense. I know that operationally it's not any different. So this is the thing that we're going to say next. Otherwise, we're going to say 0. And then we say, hey, let's now actually store this to be the previous index. And then previous is equal to, or prev is equal to cur. So it is interesting that we only use I minus 1 twice. But you know what? I don't want to mess around with the minus 1s because I'm pretty happy with this. Cool. Well, if I could have come up with this initially, I'm willing to bet I would have placed really well, but this required a lot of thinking. Yeah, well, I hope you enjoyed, and I'll see you tomorrow.